All right, you guys, uniform motion. So we kind of did all these at once, but quick review, you guys. We did some problems where the distances were equal, like we went there and we went back, okay? That's equal distances. We did some problems where we added something to get the other distance. So maybe one person started 10 kilometers ahead, and then when did they catch each other? That's that type of problem, okay? And then we've got when two distances add to be another distance. So that's technically what 94 is, when we're adding two distances to be another distance. So let's try it. A southbound bus left Fort Walton Beach at 9 a.m. 2 hours later, a northbound bus left the same station. So we have southbound and northbound. So our picture means if we're going north and south, we're going in opposite directions, right? So we need arrows going opposite directions. And we've got a southbound bus, so I'm going to do distance of the southbound bus. And we've got a northbound bus, so distance of the northbound bus. If the buses traveled at the same rate, and we're 352 kilometers apart at 2 p.m., find the rate of the buses. So it's saying the rates are the same, but let's find what the rates are. All right. So 352 kilometers apart. So that means we can add the distance that the southbound bus went and the distance that the northbound bus went, and that has to equal 352 kilometers. Okay. And so, Evan, what do I always replace distance with? Good. So we have rate S times time S plus rate north times time north equals 352. All right, they're giving us a bunch of starting and ending time. So the southbound bus left at 9 a.m., right? And we're ending at 2 p.m. So the southbound bus left at 9 a.m. and went till 2 p.m. So how many hours is 9 a.m. to 2 p.m.? I agree with you guys, 5 hours. So the time of the southbound bus is 5 hours. Then it says that 2 hours later, the northbound bus left. So Ella, if that bus left 2 hours later, how many hours did it travel for? Yep, 3 hours for the time of the northbound bus. Okay, then it says the buses traveled at the same rate. So off to the side, I can write the rate of the southbound equals the rate of the northbound. So you can pick whichever variable you want. I'm going to do both of them as RS. So they're the same, so I'm going to use RS. Or you could use both RN. So I have 5RS plus 3RS. So those actually add to be 8RS. And divide both sides by 8. So let's see, 8 goes into 32. How many times? Okay, 35 minus 32 is 3. So we have another 32. 8 goes into that 32 4 times. And we were in kilometers per hour. And we also need to say, because it asks for both rates, we also need to say the northbound rate is the same since they're equal to each other. Makes sense? Let's see. That one's kind of... Well, let's do this one. All right. The ships were 400 miles apart at midnight, and we're headed directly toward each other. Okay? So our picture is going to look different. They're starting a certain distance apart, and they're heading towards each other. Okay? Total distance is still 400 miles here. If they collided at 8 a.m., yikes, find the speed of both ships if one was 20 miles per hour faster than the other. All right, so first we've got the two different ships. It doesn't specify, so we'll just do distance 1 and distance 2. So the distance of one of the ships plus the distance of the other ship is 400. All right, and we always replace these with rate times time, rate times time. All right, so let's see. They were 400 miles apart at midnight, and they collided at 8 a.m., right? So both their times are the same, right? What should we put for both their times? Yeah, so midnight to 8 a.m. is 8 hours. So we're going to plug in 8, and we're going to plug in 8 for both times. Then we need to write a side equation for the rates. So off to the side it says find the speed of both ships if one was 20 miles per hour faster than the other. It doesn't specify which is which, right? So it actually, we can write this equation 2 different ways, and you're going to get the problem right either way because it doesn't specify. So anyone have an idea how we could write that equation? Isaac? Okay, yep, one was 20 miles per hour faster than the other one. We could have also said rate 2 equals rate 1 plus 20 because it doesn't say which is which. We're just going to find one that's faster and one that's slower. All right, so let's replace R1 with R2 plus 20. And now we can distribute. So 8 times R2 is 8R2. And 8 times 20, so plus 160. We can put the number in front here, so plus 8R2 equals 400. So I'm going to add my like terms. That's 16R2. And at the same time, I'm going to subtract 160 so I can get it over on this side. Bless you. So what is that? 240? Okay. And divide by 16. Anybody got that for me? 15. Cool. And let's see, we're in miles per hour. This is a rate, so 15 miles per hour for R2. It did say find the rate of both, so we need to go back up here, plug 15 in for R2. So what's the rate of R1? Good, 35 miles per hour. Cool. Let's try one.